what we're going to do now is look at what's called trig functions of a right triangle. And they're called sine, cosine, and tangent. And all you need to know, understand these is what the sides opposite and adjacent are. So we have an angle, which is often called theta, and the side that connects that angle is called the adjacent. The hypotenuse is always across from the 90-degree angle, and then opposite, the side opposite of theta is our opposite. So if we want to do, this is often called SOHCAHTOA, is one way of remembering. The sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is always opposite over adjacent. These are the ratios that we're going to create. So we want to find the values of our trig functions, and there's 6 of them. And so let's just do our basic sine. So sine of, in this case, theta equals, so sine is the opposite, which is 8, over the hypotenuse. The hypotenuse is across from 90-degree angle, 17. So there's our sine. Then we can do cosine theta. Cosine is adjacent. So adjacent to this theta is 15. And that's over our hypotenuse, 17. Then we have our tangent of theta. And tangent is opposite over adjacent. So opposite is 8 and adjacent is 15. So opposite over adjacent. And what's nice is that the cosecant, which is, let me write this correctly, the cosecant is just the flip of the sine. The cosecant is just the flip. So if I flip 8 over 17, the secant, S-E-C of theta, is just the flip of cosine. So that happens to be 17 over 15. And then the cotangent is just the flip of tangent, so it's 15 over 8. So these are just inverses of this. So how I remember is if we have an S, then our opposite is the C. If we have the C, then our opposite is the S. And then this one should be pretty simple. Tangent and cotangent have the word in it. So we want to look at the cosecant, the secant, cotangent after you do the sine, cosine, tangent. And this is all memorized through what's called SOHCAHTOA. So what we want to find is the trig ratios, and they give us certain information. And so they give us the sine, so we want to find the other 5. And to find them, we have to have all 3 sides. So we need to figure out what A is. And to figure out A, we're going to use the Pythagorean theorem. So A squared plus B squared equals C squared. So A we don't know, but B is 5. And C is the hypotenuse, so it's 8. And so if I go A squared plus 25 equals 64 minus the 25, I get A squared equals 39. If I take the square root of both sides, A equals the square root of 39, because that doesn't come out evenly. So you just leave that from your calculator. Now what we can do is find the 5 remaining. Well, sine is, so this is now square root of 39. So sine of B we already know is 5 over 8. They tell us that. So let's do the cosine. So the cosine is the side opposite or the side adjacent, and the hypotenuse. So the adjacent is the square root of 39, because that's what's next to B, over the hypotenuse, which is 8. And then the tangent is opposite over adjacent. So opposite is 5, and the adjacent happens to be square root of 39. So now if we go to our cosecant, well, the cosecant, remember, deals with a sine, so we flip it. So if I flip 5 over 8, I get 8 over 5. And then the secant, which is the opposite of cosine, I flip 8 over square root of 39. And then cotangent is the flip of tangent, so I flip this over, and there's the other 5 remaining.